Hello and welcome to this video tutorial on how to use CRESUS for collaboratively eliciting potential organizational and IT infrastructural requirements through enhancing shared understanding around communication and business process modeling of a scenario. The CRESUS approach incorporates several techniques for requirements elicitation, namely the interview, brainstorming, controlled natural language, stub implementation and prototypes, modeling techniques, and in particular modeling a scenario. The techniques are combined with process guidance for the stakeholders. The approach consists of 4 phases. Phase 1, the problem understanding. This phase consists of an interview with the business executive to get an understanding of how the process works and the issues with the current process. Phase 2 is the domain modeling. This is conducted as a brainstorming session where the stakeholders define the concepts and key relationships of the problem domain. These concepts and relationships form part of the concept model and actions model. For example, in the vehicle registration system, which we will look at shortly, you will have a clerk that issues registrations. This represents concepts such as clerk and registration, and actions such as issues. The conceptual model is then approved by all stakeholders. The business executive and users are the key stakeholders during this phase. The requirements elicitation forms phase 3 and consists of 2 sub-phases, namely the requirements gathering phase and the generation and testing phase. In the requirements gathering phase, it incorporates controlled natural language as an elicitation technique. The primary stakeholders that are active in this phase are the business executive and users of the system. They define the instance data. For example, John Smith issues registration 102455. There is also an incremental approval process in place. Each statement that is gathered is approved by the other stakeholders. The approved statements form a triple of controlled natural language requirements that form part of the instance model. This phase concludes when all stakeholders indicate that they have completed the phase. The generation and testing phase incorporates stub implementation as a requirements elicitation technique. The stub implementation is automatically generated from the concept model, instance model, and actions. The stub implementations have limited functionality and interactivity. Concepts such as clerk is mapped to a web service. Actions such as issues are mapped to operations in the web service. The last concept of the triple, such as registration, is mapped to parameter data of the operation. A series of discrete web services that form the IT stub architecture are created and deployed on the server. The instance model is transformed into a series of XML files that are stored in an online database. The stakeholders, especially the IT architect, will be able to critique the web services, interfaces, and data models. The stakeholders are given a tester's view of the deployed web services, where they can add additional instance data to the instance model through the web service API. This phase concludes when all stakeholders indicate that they have completed. The fourth phase, business process modeling, incorporates modeling a scenario through controlled natural language. All stakeholders are active in this phase. This phase combines the business executive and user's view of the process with the IT architecture's view of the stub implementations. The web services are mapped to pools in the business process model. A scenario is created that incorporates intelligence through tasks and sequencing of the process activities. The artifacts produced in this phase are the business process model and IT stub architecture. The business process model can be mapped to an executable process language such as BEPL and deployed on a server. Let's look at an example. In this case, the vehicle registration system. For this problem domain, the Texas Vehicle Registration System allows owners to register new vehicles such as car, truck, motorcycle and van. The vehicle contains details such as their name, address, phone number, license number, make, model, fuel type, color, and the year the vehicle was manufactured. A clerk at the vehicle registration department can verify the owner of a vehicle. The truck can be either commercial or non-commercial. For a fee, the owner is issued a new registration. For the registration of older vehicles, the system calculates a renewal fee. For commercial trucks, the owner is required to confirm an emission check which gives an emissions value. The owner is then issued a renewal notice. The owner can then make an online payment. By analyzing the problem domain, we can identify the following concepts: clerk, fee, owner, payment, registration, vehicle, of which there are car, motorbike, van, truck, and truck can be further divided into a commercial truck and a non-commercial truck. From the problem domain, we can identify the following actions: calculates renewal fee, confirms emission check, is issued to, issues new registration, issues renewal notice, makes online payment, owns, provides, verifies ownership. There are additional actions such as has address, has amount, has color, has credit card number, has credit card type, has fuel type, has license number, has manufacturer make, has manufacturer model, has year of manufacture. To understand the instance data, we take a look at the controlled natural language requirements that form a triple in terms of the concept, action and concept. For example, owner has license number integer. In terms of the instance data, it's Jane Doe has license number 234222222. Another example is a motorbike has fuel type, some string. For example, motorbike 1 has fuel type petrol. Another example, motorbike has manufacturer model, string. The instance data is motorbike 1 has manufacturer model, Goldwing. Each controlled natural language requirement will go through an approval process by the stakeholders. The stakeholders are represented by three roles in the system, namely the business executive, the IT architect, and the users of the system. If the business executive creates a requirement, then according to the approval process, the requirement will go to the user for approval. If approved, then it will go to the IT architect. Likewise, if the user creates the requirement, it will go to the business executive for approval and then to the IT architect. For example, if user A submits the following data or requirement, van 1 has color red, that data will then go to the business executive for approval. If approved, then it goes to the IT architect for approval. If approved, the data then forms part of the data model.